Today we will discuss the projectile motion. And projectile motion today will is about the equation of trajectory for ground to ground projectile. Equation of trajectory for ground to ground projectile. As we earlier discussed, we already knows that kinematic equation like y equals to uyt minus half gt square. Uy is the velocity, component of velocity in vertical direction is a u sine theta, and t is the time of flight, minus half g t square. And from horizontal range we can say x equals to ux into t. Here ux is horizontal component of the velocity, the u cos theta, and t is the time of flight. So we can calculate the value of capital T will be x by u cos theta. We can give it the first equation and the second equation. Now put the value of capital T from equation 2 to equation 1. So we'll get y equals to u sin theta x by u cos theta minus 1 by 2 g x by u cos theta. We can modify this equation like y equals to sin theta by cos theta will be tan theta, and u will be cancelled out, so it will be x tan theta minus gx square by 2 u square cos square. So it is the equation of trajectory for ground to ground projectile. Now we will study about the horizontal projectile. Horizontal. Let a particle be projected horizontally with initial speed, you can say with initial velocity. Initial velocity u from height h. Any object is thrown from the from some height h in horizontal direction, then it will move like that, or you can say it follows path. It follows the parabolic path. This initial speed is u in horizontal direction. Its vertical component uy will be 0 because u cos 90 will be 0, and at any point horizontal speed vx b u will be same, and in vertical direction vy will be, well, vy will not be 0 here, and the direction the particle, so vx and vy will be the component of v. You can say if it makes angle alpha with horizontal, and this is horizontal range covered by the particle during the projectile motion. We have Vx equals to u, and Vy will be Uy minus Gt, and we already know that Uy means velocity, component in vertical direction will be 0 to minus Gt, so Vy will be minus Gt. So write in vector form, then we can say V vector will be Ui vector uik minus gtjk. If you want to find out the equation of trajectory, let x be the displacement of particle along x-axis at any time t. So we can say x equals to ut or t equals to x by u. X is a displacement x direction, and u is a velocity in horizontal direction, and t is a time of flight. So you can say t equals to x by u. Let y be the corresponding displacement on y-axis, then y equals to minus half gt square. As I know, velocity component in y direction will be 0 because u cos 90 will be 0. So y equals to minus half gt square, and we can write half g t will be x by u. We already studied in above equation, half g x by u all square. So y equal to minus half g x square by u square. It's a trajectory equation for horizontal projectile. Now we can find out time of flight. Time of flight for horizontal projection is denoted by capital T. We can say S equals to ut minus half plus half gt square. You already know that will be minus h, and component of the velocity in vertical direction will be 0, or g will be negative, so minus half gt square. So t will be root 2h by, so we can write also capital T equals to 2h by g. It's the time of flight of the projectile in horizontal projection. Now we'll discuss about the horizontal range. As you already know, r equals to ux into t. R is a range, horizontal range. Ux is a component of the velocity in horizontal direction, and t is the time of flight. So distance equals to velocity into time. Okay, and we already find out the time of flight. So ux into root 2h by g, and velocity component in horizontal direction is always be same, so it will be u root 2h by